Hey guys, good morning or afternoon. I don't know when you're watching this. Good evening. Let's see. So this should be another one of those pretty short kind of review, maybe a few things you don't know, but you still need to watch it because we're adding on. Okay, so this is going to be classifications of matter. Let me share my screen and go ahead and get ready to start writing. Get this screen mirroring, zoom. Okay, let's get back here to my note. Okay, so once again, we're going to be looking at classifications of matter. All right, and anxious to move on to the next topic. All right, but we can't, Ms. Murphy can't skip the simple stuff. All right, got to build a foundation here. Okay, so we know that we've got elements. All right, those are the ones on the periodic table, and elements are composed of ions. Composed of atoms. Right, atoms is the smallest sample of a piece of matter, right? Smallest sample of an element that retains the properties of the element, right? The properties of that element. Right, so over here, I could have like an awful lot of silver atoms. Let's call these silver atoms, right? We're just going to say that this is my element silver, Ag, silver, right? Each of these is supposed to represent a silver atom. Okay, pretend I wrote Ag in every one. Well, let me go ahead and write Ag in every one. Maybe you don't want to draw so many circles, right? If I was to take one of those and put it over here, I would now have an atom of silver. This is my element, silver, same atoms within the element. They're all silver atoms. And this here is just my atom of silver, okay? And then we've talked differently about atoms, but those are classifications. Is it an atom? Is it an element? Well, the element's going to have many atoms in there typically. Okay. We would then talk about compounds. All right. Now, compounds to me, or in definition, are composed of two or more different, it's key words, got to be there, right? Different elements. And those that are chemically bonded, all right? So I can't take a silver element and put it and mix it with a lead element and call that a compound because they're not chemically bonded, right? These compounds, they have a definite composition, right? Definite composition. We will calculate those compositions. They have a definite composition. So some compounds, carbon dioxide. What I mean by definite composition is it's always going to be one carbon bonded to two oxygen atoms. That composition for carbon dioxide will never change, right? If it changes, then it's not carbon dioxide, right? It's not CO2. So that's what we mean by definite composition. And we can see that in this compound, there are two different elements. However, there are a total of 3 atoms, right? 2 of which are oxygen, 1 of which is carbon. We could have another compound and it might look something like this, right? That would be a compound that contains 3 different elements. Let me write this actually over here. it would contain 3 different elements. What are those elements? Well, we see that in this compound, we've got aluminums, we've got nitrogens, and we've got oxygens. How many atoms are in this compound? Right? How many atoms are in the compound? Well, let's make sure we understand how to look at this. I would see this as 1 atom of aluminum, right? 1 atom of aluminum. Now there's 1 nitrogen in here. However, I have 3 of those. So I have 3 nitrogen atoms. And I have 3 times 3 is 9 oxygen atoms, right? So I would see this as a total of 9 plus 3 is 12, plus another one is 13. I have a total of 13 atoms in the compounds. Okay, cool. So those are our compounds. Now, we also have something called molecules, and I know that you guys are going to do a Brain Genie assignment. I don't really like the way Brain Genie deals with their molecules. Brain Genie says that compounds are molecules, okay? Now, for me, molecules, I just have a different definition, but I'm going to save my form of that definition for you, okay? So I will proceed with, let's look at a molecule, something like H2, right? So molecules do not necessarily have different types of elements, okay? Such that H2, this is a molecule, but not a compound. So for Brain Genie, they work with the thought that all compounds are molecules, but not all molecules are compounds, because this cannot be a compound, because by definition, a compound has different elements, and this does not, okay? Now, some molecules have allotropes, and I think the easiest way to tell you what an allotrope is to kind of give you an example. We could have carbon. Carbon can come in 3 different forms. It can be graphite. This is an elemental allotrope. This is an elemental allotrope. It could be graphite. It could be diamond. Or it could be something called fullerene. Okay? But they're all carbons. All right? Another one would be like phosphorus. And I hope I get this right. There's a P4 and there's a P10, right? One of them is red phosphorus, one is white phosphorus. I'm not sure which one, so I'm not going to write it, and I apologize for that. But you see that it's the same, but different, okay? These are all carbons. These are molecules. As you see, these are carbons, and the difference is how the carbon atoms, so these are more elements. The difference is how those carbon atoms are bonded to each other. And that's what changes the form of carbon that you have, whether it's graphite or a diamond, is how each individual carbon atom is bonded to its neighboring carbon atom or atoms. So that's the big difference there. Now, so, you know, we've got elements. If it's on the periodic table, it's an element. All of our stuff, everything is composed of elements. When you rearrange the elements, you rearrange the properties of the substance. We've got our compounds contain different elements. Our molecules are not compounds because they don't have different, or molecules are not always compounds, okay? I don't want to get too much in that. I'll save it for later, the way I really think about it. And then we would get to something called mixtures, right? And we can have two different types of mixtures. They are typically homogeneous. And homogeneous mixtures can refer to as solutions. Okay, they are solutions. We will have heterogeneous mixtures, and those are not called solutions because homogeneous mixtures have a constant composition, right? We kind of talked about this when we talked about intensive properties, and we said composition. I'm actually going to change that. They have an unchanging concentration within each solution, right? I could have a high concentration versus a low concentration, but they are homogeneous. That means whatever that concentration is, it's consistent throughout. Okay. So I'm going to write that. That's important to realize it's consistent throughout. And what we have here is we've got elements or atoms or compounds mixed together, but not chemically bonded together, right? So they can be separated physically. We can easily separate them. Whereas compounds, right? If we look at these compounds up here, I cannot separate this. It must be separated chemically, right? I must do something this to break the bonds. Oops, let's put that word separated in there. I've got to break those bonds chemically. I can't just physically manipulate the compound apart. However, with a mixture, I can separate those apart. We'll talk about that in a minute. And I can physically separate them. Therefore, remember these dots mean therefore, they can be physically separated, okay? And we'll talk about that. That'll be the last thing we talk about. They can be physically separated. What are some examples? This would be like homogeneous mixture, salt, water. Air is a mixture of a lot of gases, and they're all evenly dispersed, so it's the same throughout. So that would be considered a homogeneous mixture. Coffee, right? Coffee, anything that's the same throughout. I'm having a hard time thinking of anything right now. Alloys, let's go ahead and put that on here, alloys. And what an alloy is it's a mixture of metals, all right? And those are evenly dispersed in that mixture, okay? So that would be a homogeneous mixture, okay? Homogeneous mixtures would maybe look something like this. Maybe we've got this, 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 and then we've got some of these and these and these. And then we've got, and I'm sorry, we've got some of this. Oh, I wanted that to be the same color. We've got some of this and this and this. And then again, we've got some of, I hope I picked the right color. Let's just make that this color. We've got some of these. So you see, I've got a constant distribution. It's a composition, the distribution is the same throughout. Okay, that's not an alloy. That's not an alloy. That's just what a homogeneous mixture would look like. Okay, it's a particulate. We call these particulate diagrams. Okay, let's move on to our heterogeneous mixtures. Very, very common. Mixtures are everywhere, right? Everything in this room is mixed together. Not everything, but all my stuff. So these are not referred to as solutions, and they have changing concentrations, right? Changing concentrations such that It's not consistent throughout. Not consistent throughout. Easy to identify because you can identify individual pieces of them. I mean, it's so easy to come up with examples. You're talking about chocolate chip cookies. Chocolate chip cookies. Cereal, trail mix, right? Cereal, trail mix, all those things, spaghetti. Now, on Brain Genie, it's going to put milk as a heterogeneous mixture. I personally would have chosen homogeneous. It's homogenized milk, but I guess they're considering milk, just imagine old milk, okay? So when you get to Brain Genie, when they give you milk, they want it to be heterogeneous. Doesn't make sense to me. Also, Brain Genie tip, cappuccino, heterogeneous, okay? Because I guess they have the bubbles on top of your cappuccino. You know, they put that thing in there. And orange juice, there's one Brain Genie. It says without pulp, that's homogeneous. And then they also mention orange juice, and they don't mention pulp at all, homogeneous. So orange juice, Brain Genie, homogeneous. Milk and cappuccino, heterogeneous. Those are just kind of outliers, right? Okay. Let's finish this up. The last thing we're going to look at is ways to separate. Ooh, don't want that. Methods or ways. I'll use the word ways to separate, or let's just write separating mixtures. Separating mixtures. Okay. And I actually took a picture of a couple of things I wanted to make sure that, okay, just to help you with your Brain Genie assignment. I did it so I could see what you would be faced with. Well, we've got filtration here, right? And y'all know how you filter something. If you've ever made coffee and the water goes through the filter and the coffee grounds sit on top, right? How did we separate it? We separated based on particle size, right? So when we have particle sizes that are very different, we can filter them out. Okay, that's cool. There's something called distillation, and we use that process to separate liquids and based on boiling points. So in order to use the process of distillation, the liquids need to have very different boiling points. And what we do is we heat to boil, right? You set up this whole apparatus, and imagine you had your two liquids in here, right? So we had two different things going on in there, and we needed to get them separated. We could add some heat down here. We could do a whole bunch of stuff, to be honest with you, and kind of go like that to simplify it. We don't need that last part. I'm not going to worry about it. But when we add heat, the substance with the lower boiling point, right, will evaporate the first, and we'll see it go up through here. We then throw some water in there to cool it down and condense it, and then we would end up with it over here. Okay. So we would distill it, separate it based on boiling points. Obviously, the two liquids have to have different boiling points in order to do that. Another method of separating mixtures that you need to be aware of would be something called chromatography. Okay. And that is going to involve separating substances based on their polarity. And I hate giving you that word because I know that you don't understand it yet, but we could use chromatography to separate two soluble liquids. That means liquids that are mixed together. They have been mixed together. And let's say they have similar boiling points, so we can't distill them, And we would separate them based on their polarities. And those polarities, once again, would need to be different. So I'm gonna write their differing polarities. Now you don't know what polarities means, and it's kind of has to do with its attraction for other substances. But that is what chromatography is going to do. You can separate dyes in your ink, right? So if I have this marker here and I want to separate all the different colors that make up the red, I could do something like chromatography. All right. And guys, that is going to end our lesson here on classifications of matter: elements, atoms, compounds, mixtures, solutions. I think that does it. I hope I didn't forget anything. Okay, I'll see you later.